I realized something though when I was going over the homework with my classes today that I did not teach you guys about forces on an inclined plane when we first were going over forces. So that might have been a little confusing to you how to actually orient that particular type of triangle. So I'm going to show you guys what you need to do with the problems. Let's see, it's numbers 4 through 7. How to deal with that triangle thing. And then I'm also going to give you guys a little going over of this assignment here. Mr. Scharnhorst should be able to explain things very well also. Okay, so we didn't really talk about forces on an inclined plane back when we first talked about forces, so let me talk about that for a second. When we have a force on an inclined plane, or when we have an object, I should say, sitting on an inclined plane, automatically you know that gravity is going to be pulling it down the incline somewhat, right? Always. And what happens here is we've got gravity always acts what direction? It acts straight down, always. So here's gravity. This is the weight of my object, Fg, right here. Okay, so I think the weight of the object in this particular problem was 5 kilograms. So this would be 5 kilograms times the acceleration due to gravity. That would be its weight, right? Okay, so that's what's happening over here. Now, I told you guys the angle that this is right here. I believe this said 25 degrees. What I didn't tell you guys was how you deal with that, the angle of the incline, as opposed to the angle that you're pulling on an object with. Here, we were just doing, if this is my angle, we were just doing force times cosine theta times our distance to get work. Here, our force is pulling straight down, but what angle is that to the actual surface? That's the question. So what we need to think about is the surface is our x-axis, like that. Okay, so this is my x-axis. So it's kind of tilted. Instead of the x-axis being flat, we've taken a flat x-axis and we've turned it on its side, or we've tilted it up. So this is now the x-axis, and perpendicular to that is my y-axis. And there's y. There you go. Okay, so now we've got some stuff that can help us figure out a triangle. We want to know how much of this weight is actually acting parallel to this surface. So what I want to show you guys is we can draw a triangle here, like this. And the right angle is going to be here. And now you might be thinking, okay, well that's nice, but I don't know any information about that triangle. Not actually true. You know the hypotenuse. You know that that's the weight of the object, how heavy it is in newtons. And you actually know the angle that's down here at the bottom of this triangle, because this angle right here is actually the same as this angle right here. These are similar triangles. And if you can show me through your knowledge of geometry and trig how those are congruent, then I will give you 3 tickets. You have to draw it out for me and explain the proof to me, and 3 tickets for you, okay? All right, if you're like, ugh, trigonometry makes me just want to cry, then you don't have to worry about that. You just need to then take my word for it that these are, in fact, congruent, okay? All right. So what we're doing here is we've drawn our triangle so that it's going right along with the x-axis parallel to this surface here, and then we drew down, and the weight is our hypotenuse, okay? Now, if we're looking for this side over here, then this side, which we're calling x, notice that x is not adjacent to this angle. It is opposite to this angle. So if you want to know how much force is acting in this direction, it's actually opposite, not adjacent. So you need to think about how we need to change this formula so it will work for this kind of a problem. Okay? That's where I'm going to leave you.